Welcome back. In chapter 8, we're going to be talking about frameworks and reuse, designing with interfaces and abstract classes. We are reading the book, The Object-Oriented Thought Process by Matt Wakefield. And in this chapter, we'll be introducing new concepts called frameworks and interfaces. Interface is a software terminology which can have different meanings. Do not be confused with graphical interfaces, class interfaces, which are the ones that we've been talking about in this book. It is important to use each in the proper context. Okay, next, what is a framework? A concept that goes hand in hand with code reuse is the concept of standardization, which is sometimes called plug and play. The idea of a framework revolves around these plug and play and reuse principles. A framework is a system which is generic enough to be reused in multiple systems or projects while still allowing the system using the framework to be unique. Consider a Microsoft Office application. Ironically, we are not using Microsoft Office, we're actually using Office Libre, which is an open source application. The framework would be the windows, toolbars, tools, icons, etc. All that the Microsoft Office application shares. Although all of the Microsoft Office applications have a framework, Although all of the Microsoft applications have a framework that they share, they all have different purposes and are unique. Although they are built on the same framework, Although they are all built on the same framework, they are all unique and able to accomplish different things. So, a plug and play or framework. I'm going to give a quick example on what that is. So basically when we think of frameworks, we're just going to think of, let's just think of wireframe. Okay, but of course in this concept we're talking about code framework. But just to illustrate it, we're going to use wireframes. Okay, so now I'm not the best designer in the world, so bear with me. I'm not a designer, and that is fine with me. And this would be the contact. So consider this a framework, although this is actual code or an actual design, we would be able to put a different kind of navigation. Could be black, blue, green, Spanish, English, whatever you like. Could say home, casa, bonito, frijoles, tortillas, hondureños. I'm just kidding. Right? It can have a sense of it's being unique, right? This could be maybe for images, some sort of slider, right? But they wouldn't be the same images. It could be different images for a different type of website. It could be e-commerce. It could be a store. It could be a bookstore. It could be a fast food restaurants, pizza, hamburgers, library, Barnes and Noble. Could be whatever you like, right? And let's say these are just tabs to different things for the website. Let's say about, home, contact, whatever you like, right? And let's say this is our footer. Right? It would have different information. Although this technically in software architecture, the template would be more like a framework because it's holding everything together. All you would have to do is plug in things into it, the images, the navigation, the contacts, the links, and everything else on there. So in this sense, this template which is a template in design, in web design, would equal to framework, at least in the concept sense. What is a contract? In this chapter, we will consider a contract to be any mechanism that requires a developer to comply with the specifications of an API. A contract can be considered the requirements that the interface and abstract class requires in order to function correctly. Without plugging into the interface and abstract classes, their framework will not work properly. So if we go back to this example, right? A contract would be something where if the template doesn't contain these images, the template will not even run. That's what we would consider a contract, right? If this template does not have the navigation bar, it would not run. It's the same thing from framework, right? We're considering the contract all the abstract methods and all the interface methods that are passed on to their subclasses, or they must have some sort of implementation for them. That is what we are considering a contract. And I'm sure that anybody that's used APIs before, that's actually a good way to do it. You cannot plug in an API without actually supplying the API with information it needs. The API would just not work. Okay, next it's abstract classes. Okay, an abstract class is a class which provides methods to its subclasses but does not provide any implementations. It is important to remember that if a subclass does not provide an implementation for the abstract methods which its parents provided, the subclass will become an abstract class itself. Another important thing to mention is that every class should be responsible for itself and should provide its own version of the abstract method which was provided by its superclass. Okay, next is interfaces. An interface is very similar to an abstract class but does not use the word class. Interfaces provide only methods and do not provide any attributes. Interfaces also require the classes which they provide methods to implement the methods which was provided to them. Okay, next. Abstract classes versus interfaces. This is very cool. One of the main differences between abstract classes and interfaces is that the abstract classes are built on is-a relationships, while interfaces can actually fall under different classes with has-a relationships. That is very important to know. It is very important to note that an interface is not a composition class. Interfaces provide methods to classes without attributes or implementations, and the classes receiving from it must implement what is being passed to them. For the sake of making it easy, I did not include all of the code. I only provided how the dog class wrapper is created. The dog class has a head through composition, the dog class is a mammal through inheritance, and the dog class has a name through an interface. A lizard class can also have a name through the same interface, but the lizard class cannot be a mammal. The dog class and lizard class would not have any type of relationship, but the same interface could still be provided to both of them. That is the difference between interfaces and abstract classes. Okay, so now for the final finale. Tying it all together. It is very important to understand the key differences between abstract classes and interfaces. While we can still use abstract classes to pass attributes and functionality using an is-a relationship, keyword is a relationship, we can also use interfaces to pass functionality to classes using has-a relationships, even if the classes do not have an is-a relationships. Okay? In the following example, we'll be using a framework which makes the system usable for different systems, but it can also include a class which would make the systems unique once applied. Take a special note to how the donut shop and pizza shop are the same class but different objects. They contain their functionality from the nameable interface and the shop class. The shop class is a compound class and contains a cust list for customer list class. Although the donor shop class and the pizza shop class are the same class, their objects contain different attributes stating the differences. For example, in this example, their names and their functionalities, which are received through abstract classes and interfaces. So that is the main difference between the abstract class and the interface. Remember, we're not talking about interfaces we're not talking about public interfaces. We're talking about interfaces which supply methods to other classes. So that is it for now. I will leave these notes for you guys to download and look at these little cool charts. The only thing that you guys will not get is my cool template equals framework, which that is copyrighted, by the way. Just kidding. But I'll see you guys next time.